What's up, guys? Today I'm doing a video on solving quadratics, and we're going to focus on two methods: that's solving by taking square roots and solving by the quadratic formula. Okay, solving by taking square roots is a nice method because it's very quick and very easy if the problem is set up the right way for it. Solving using the quadratic formula is nice because while it is a lot more work than the other one, the nice thing about the quadratic formula is that it always works. You can always solve for the quadratic formula no matter what type of quadratic you have. Okay. There's another method called solving by completing the square. Sorry, by completing the square. I'm not going to be covering completing the square, even though it is useful in some of your later classes. It's just not very useful in our class. So in order to keep everything kind of focused, we're not going to be doing completing the square. Although if you ask me at some point, I can definitely show it to you if you're curious. It's a pretty cool way to do it, but it's just as much work as the quadratic formula. And so you really only need one method, I think. All right, solving by taking square roots. Simply, as I like to call it, doing algebra. Okay, it's really just looking at it and saying, I'm going to do inverse operations to get x by itself. Okay, so when I say solve by taking square roots, the problem has to be set up a certain way. You can't always solve them this way. Generally speaking, you're only going to have two terms. Or if you have more than two terms, it'll be terms that you can combine to where you do only have two terms. So in this case, I can solve by first dividing on both sides by 3. Okay, so I'm going to say x squared equals 25. And now I simply need to take the square root on both sides. Okay, now if you remember, when you take a square root on both sides of an equation, you have to say plus or minus. Okay, so when I take the square root over here, I just get x. And when I take the square root on this side, I've got to say plus or minus the square root of 25, which is 5. And so that's the answer, plus or minus 5. Meaning, if I were to plug a 5 in here, I would get 75. So it would be a true equation. If I were to plug in a negative 5 here, I would also get 75. All right, number 2. We got an extra step. Okay, so like I said, there's more than two terms here, but when I subtract that 10, in other words, combine those like terms, I'm going to be back down to two terms. Okay, so I'm just going to go ahead and subtract that 10, and that gives me 32. I'm going to divide by 2 on both sides. That gives me 16. And now I'm just going to take the square root. And the square root of 16 is 4. So I got to say x equals plus or minus 4. That's two solutions. Okay. All right, so then solving using the quadratic formula. You should know how to do this already. This shouldn't be the first time you've seen it. I rewrote it here for you. That's negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. And make sure you remember everything's divided by 2a. Okay, this fraction bar has to go all the way across. And that's, of course, referring to the standard form of a quadratic, which is ax squared plus bx plus c when it's equal to 0. If you don't have a 0 on the other side, then you got to do some work to get 0 on this side. Okay. Here's a couple problems where there's already a 0 on the other side. I just made these numbers up. I had no idea what kind of answers I'm going to get. Maybe they'll be imaginary, complex. There's no telling. And that's the nice thing about the quadratic formula is you can just make some problems up and they'll always work. The quadratic formula always works. All right, so I'm going to say x equals negative b. So remember, it's a, b, and c. Negative b plus or minus the square root of b squared. And I like to go ahead and just square it. It avoids sign issues. What's 2 squared? That's 4. So there's b squared minus 4 times a times c, all divided by 2 times a. All right. Let's just work this down a little bit at a time. Try not to do too much at once. All this part under the radical, I'm going to go ahead and figure that out. So 4 times 3 times 4. Okay, that's 36, right? 4 times 3 is 12 times 4. Sorry, that's 48. Okay, 48. And use a calculator if you need to. Okay, but that's 48. And so you've got 4 minus 48, okay, which is negative 44. Okay, put this in a calculator if you need to. Okay. Now, this negative sign should already tell you what kind of answer you're going to end up getting. It's going to be complex or imaginary. All right, so 2 times 3 is 6. All right, so what do we need to do? Well, we need to pull the negative sign out because we don't leave negatives under radicals, right? And then we need to simplify that square root of 44. So, this goes back to the lesson we did on simplifying radicals. Again, you can see why it's important. We're going to be using that skill throughout the rest of the class. That's -2 plus or minus. This is going to simplify as the negative comes out as an I, and there's a 4 that comes out as a 2. If you need to go back and review your simplifying radical skills, then do that. But this is going to be 2i times the square root of 11. That's how that's going to simplify, over 6. And now we got to go one more step. We might be done here sometimes, but in this case, look at all three terms. There's a term here, and a term here. Is there something I can divide out of all of those so that I can reduce my fraction? And there is. I can divide everything by 2. Now, if I can't divide all three terms by 2, then I can't do anything else with it, okay? So I'm going to divide everything by 2. That's going to be -1 plus or minus I. You don't divide the part under the radical, over 3. And that would be my final answer. Now, I said a minute ago, if you can't divide all three terms by something, then you leave it alone. Well, there is one exception to that. If, say that only these two would reduce, but this term doesn't, you can split this apart into two separate fractions. I'm not going to make you do that. In fact, I usually won't do that. But you should be aware of it in case you're looking at a multiple choice problem and maybe somebody did that. Shouldn't be a problem in this class. I always say if you can't reduce these, then let's just leave it how it is. If you can, then you need to reduce it. But all three terms have to be divisible by the same thing, which in this case was 2, gave us this answer. All right, let's do one more. And again, I have no idea how this one's going to work out, so let's see. X equals -b, so I got to say +5 plus or minus the square root b squared, which is 25, minus 4 times a times c over 2 times a. Okay, we get 5 plus or minus. How is this going to work out? See, that's 8 times 3 is 24. 25 minus 24 is 1. Oh, that worked out nice. So this is not imaginary. It's not complex. And in fact, it's not even going to be irrational, which means we could have solved this one by factoring. How do I know that? Because the square root of 1 is 1. If the radical completely cancels out, if you're able to take the square root of whatever's under the radical, then that means your answer is going to be either whole numbers or a fraction. Okay, there won't be any square root signs. If that's the case, then that means you could have actually factored to solve. Just something to be kind of aware of. So let's work this out. This is actually a 1, right? Maybe I should write that. 5 plus or minus 1 over 4. Well, anytime you get numbers like this, you might say, all right, well, can I divide all three of these by something? But before we even do that, let's look at what we have here. This is a number, plus or minus a number, divided by 4. Well, we can actually work this out. I can do 5 plus 1. What is that? That's 6 over 4. And I could do 5 minus 1. That's 4. Put a comma there. That's 4 over 4. Well, I need to reduce those fractions. What are they? This is 3 halves. And this is 1. So my two solutions are 3 halves and 1.